in this project. We, through the grant that we got from the Environmental Council, we hired two students, one who was in animal science, who's now a first-year vet student in the College of Vet Med here at U of I, and a graduate student in natural resources and environmental science, to essentially do a lot of the data collection for the project. Todd Rusk, who many of you probably know from here, the Waste Management Resource Center, was a key collaborator, particularly because of his interest in food waste composting. And then we also had assistance from the Animal Science Department, particularly Mike Catter-Henry, who manages the Dairy Research Facility as well as the beef and sheep, and the people at Allen Hall Dining Services, specifically. Carol Ann Nelson was our contact person there. So we also had involvement from Facilities and Services within that organization, the branch that manages all of the campus grounds. We didn't really have one particular person that was our point person there. Why did we do this project? Well, it's kind of a no-brainer that this university, when you look at just the grounds as well as the animal research facilities and the College of Veterinary Medicine, and even looking at the dormitories, there's an enormous amount of organic waste generated on this campus. If you look at just the dairy research facility alone, it generates around 30,000 cubic yards of manure every year. And the College of Vet Med generates about 2,800 cubic yards of soiled bedding. Campus grounds generates mostly leaves, but a little bit of grass clippings, over 10,000 cubic yards, and over 500 cubic yards of tree trimmings every year. And just one dorm that feeds 11,000 students per week generates close to 6,000 pounds of food waste per week, which is a staggering number. We were shocked to actually see how much food waste. This is an all-you-can-eat kind of a dormitory, as opposed to an a la carte menu. And in their particular case, it is pretty much all of the uneaten food on plates is put through the disposal system and goes into the wastewater system that eventually is treated by the city of Urbana. So what have Vet Med and Animal Science been doing with all of the organic waste that's been generated on their facilities? Well, up until very recently, they've been hauling it to a site on Windsor Road, kind of almost the corner of Lincoln and Windsor. I don't know if you guys are familiar with that site, which happens to be within less than 50 feet from the Embra River. So this wooded area right here is actually where the river is. And it's fairly obvious from these photos that it's a very difficult site to manage. It's not been considered a high priority. They never really focused on trying to do the best job of composting. It was just merely a matter of a convenient site for waste disposal. And as a result, they had an environmental audit this past fall. A third-party consultant came in and essentially told them that if they don't either remove the material or take some remedial measures, that they would be cited in terms of an environmental violation and would be fined. And the fines through Illinois EPA start at a minimum of like $75,000 a day. And so it doesn't take long before you can quickly see that an alternative scenario was justified. So So there's a tremendous opportunity here. There's a tremendous opportunity because of the diversity of the kinds of waste that are generated on this campus to blend them through composting and produce a really high quality product that could actually be sold, and it could be sold to the community, the Champaign-Urbana community, and it could also be sold to campus grounds, so they could actually buy it back, or if they were contributing a significant amount of the waste themselves, reuse that material in the landscaping part of their operation. And so the motivation was partly because they knew that they had a potential environmental hazard on their hands, but before that even came up, they were thinking of this as a way to reduce handling costs of these wastes, and actually consider developing an additional enterprise that could be a moneymaker as opposed to just an expenditure. So in terms of the environmental benefits, it's fairly obvious that if you're taking materials that are currently considered a waste and converting them into a soil resource, that is seen as an environmental benefit, and supposedly the campus is about reducing its environmental footprint, and this certainly would embody that mindset. And because this is a university, this enterprise could serve as a venue for students and others who were interested either in the composting or the utilization of the compost. So, these are the objectives of our project. We needed to evaluate potential sites that were going to be cost-effective in terms of their proximity to the raw materials as well as their suitability for composting. We needed to know what we had in the way of feedstock or raw material in terms of quantity, quality, seasonality, et cetera, so that we could develop a plan for how that material would be utilized. So we did a feedstock inventory analysis. We wanted to not just do composting as waste management, but composting as product development, and so it was important to identify the potential markets in our area that would be interested in purchasing a high-quality compost and what kind of characteristics they would actually be looking for and how much they would be willing to pay. Of course, we needed to determine how much it would cost to build a facility, how much it would cost to operate, what kind of labor requirements, as well as what some of the regulatory issues are for putting this type of a facility on a university campus. And then lastly, to set up some small-scale piles using all of the materials that would be available for composting, comparing two different composting technologies so that we could make some recommendations about the trade-offs of those two technologies. Okay, so the first thing that we did was this feedstock inventory. So the students went and interviewed the various feedstock suppliers for amounts that they generated either on a weekly basis or on a monthly basis. And we're mostly talking about vet med, campus grounds, the animal science department, and we focused on Allen Hall. Particularly Allen Hall because they have an interest in environmental issues. There's a group of students in that dorm that are interested in environmental issues. We also collected samples of each of these materials to analyze for the moisture content, the carbon content, nitrogen content, develop the carbon to nitrogen ratio, which is an index of the quality of that material for composting, and the bulk density so that we could go between weight and volume in developing recipes for composting. we did a food waste audit at Allen Hall, which consisted of collecting all of the food that was generated over a 3-day period, weighing it, qualitatively sorting it in terms of like what was actually in it, getting a sense of how contaminated it was with non-compostable materials and other non-food waste products that are generated, such as napkins and paper products. What we found was that a single student over the academic year generates almost 1,300 pounds of organic waste. In terms of the characteristics of it, around a quarter of it was what we call pre-consumer food waste, that is all of the peelings and discarded cabbage leaves and things that are used or discarded in the preparation of the food. The majority of it was unconsumed food left on the tray, and then there was actually 20% that was food that was completely untouched. And in some cases, they would try to, that uneaten food, they would try to get it to the food bank, but in some cases it ended up in the dumpster, sad to say. The good thing about their system is that the students just put their tray on a conveyor, and then the food is sorted by other workers in the kitchen, and as a result the waste stream is actually pretty clean in terms of non-compostable contaminants. But there is a significant amount of paper waste generated, as well as the actual food waste, almost 10,000 pounds, which is a lot of paper. Yes?
Is the paper waste compostable?
Sure, yeah. Okay, so this is a kind of a consolidated summary in terms of volume generated on a daily basis. It doesn't really give you a good sense of the seasonality. So, for example, facilities and services or campus grounds, yard debris, all of that material is generated in like a 4-month period of time. But it's mostly leaves and not much besides leaves and a little bit of brush. Whereas the materials that are generated from the dairy barns, the beef barns, et cetera, all the animal science research facilities, as well as the College of Vet Med, those are pretty consistent across the year. And of course, Allen Hall is only of significance during the academic school year, so a 9-month period. So we needed to take all of the information from the inventory, convert it into cubic yards per day, so that we could develop estimates on how big an area we needed for composting. So the total daily volume is close to 260 cubic yards per day. As I mentioned before, we have a good diversity of organic waste that are well suited to composting, in that most of animal sciences material, as well as the food waste, is wet material and nutrient-rich material. And most of the material coming from Vet Med and from campus grounds is dry, carbon-rich material. And you need that balance to have proper composting. And so it is good that we have access to this kind of diversity in terms of carbon and nitrogen ratios and moisture contents. I realize this is a little difficult to see, but basically with that information, I developed calculations to determine how big an area we needed for composting using 2 composting technologies. A windrow turn system, which is basically taking a tractor that is attached to a specific piece of machinery that runs through compost windrows and flips them and agitates them, versus what's called an aerated static pile system, which is essentially an in-place method of composting where you premix all the materials, you lay them on a bed of porous material, be it wood chips or leaves. Underneath that porous material, there is a series of perforated pipes, like PVC drain pipes. So, and then you blow air through those pipes. The air moves into the pile from the bottom up, so it's through convective airflow that you aerate the pile, as opposed to reestablishing oxygen conditions through actively turning the pile. And the main difference between those two technologies, there's big differences in terms of management, but in terms of area, that you can have piles a lot closer together in an aerated static pile system compared to the windrow turn system. So it's hard to see the actual calculations here, but taking that initial daily volume, I determined how many windrows, how far apart they would need to be based on the two technologies. The bottom line is that for the windrow turn system, for the volume of waste generated on campus of those materials that we inventoried, we'd need about 5 acres versus 2 acres for the aerated static pile. So it's a lot smaller footprint for composting with the aerated static pile. I then determined how much would be left, because that covers the active phase of composting, where you get high temperatures, you get a lot of activity, a lot of breakdown of the material, but then once the piles begin to cool down, they still continue to compost in what's called the curing phase, and so you need to have sufficient area for that curing phase, which I determined to be almost 3/4 of an acre additional space. And so when you add that to the other two areas, and then you add some additional area for storage of the finished product prior to it actually being sold, the difference in area requirements for the two systems would be around 6.5 acres for the windrow turn system versus 3.5 acres for the aerated static pile. So it's quite a difference between the two technologies, but there are other trade-offs, not just based on area requirements. The other thing that we wanted to look at were some potential compost recipes that would utilize all of the feedstocks. And so I have a program called Compost Recipe Maker. It's a little, very simple computer program that I put in the characteristics of the feedstocks, and I let the program, based on optimizing for the carbon to nitrogen ratio and the moisture content, it gives me some scenarios that meet those optimal criteria. So these are just some examples of compost recipes, and I really, there were dozens of potential recipes that you could generate based on the feedstocks that we have available. I just put together some that would be most likely to happen. One of the things that we needed to think about was how much of this wet material do we have versus the drier material to achieve the proper carbon to nitrogen ratio, which is typically anywhere from 30 to 40 to 1. And usually people recommend 2 to 3 parts of the drier material to 1 part of the wetter material to achieve that optimal initial carbon to nitrogen ratio. And what we have is closer to more like 1.5 parts of dry material to 1 part of wet material. So what that suggests is that we probably need to be bringing in additional leaves or yard debris from, say, the city of Champaign, which is actually extremely interested in having the university compost their leaves, because Presently, they've been sending it to the Urbana waste recycling facility, and they'd like to have another option. So that's another situation where partnering with an entity outside of the campus would help solve their waste problem as well. So we also, that kind of gives you a sense of the characteristics of the materials themselves and how we developed area requirements and some sample recipes. In terms of selecting a site, one of the main criteria was proximity to the wettest feedstocks, because as soon as you need to put really wet manure in a tanker and transport it even a few miles, there's enormous costs associated with that. So that was kind of our main criterion for site selection, which led us to a site that would be close to the dairy research facility, which also turns out to be close to the College of Vet Med. Of course, it's got to be soil-wise and topographic-wise. It's got to be a site that is well suited to composting. That is, it's got to have good drainage. It has to have the ability to be compacted or the ability to have some additional materials added to it to compact the soil and make the pad impermeable. And you don't want it to be draining into a water body that is considered a resource of the state. So if you you're going to have drainage off of that site, so you've got to have either collection ponds or some other way to mitigate that runoff water, leachate water, from getting into the Ember River, which right now is a big concern. The other is proximity to neighbors. People smell with their eyes when it comes to a composting facility, and so you want to find a site that does not have prevailing winds drifting over into the high-end neighborhood of Old Urbana, for example, and you don't want it to be easily visible. Not because you're doing a bad job or you have something to hide, but for some reason, and not for some reason actually, for a good reason, a lot of composting facilities have not done well with neighbor relations, partly because they have not been well managed and they have generated odors, dust, noise, etc., and that doesn't make for good neighbor relations. So it's a lot easier to site a facility that isn't in direct view of a neighborhood. And then, of course, you need to have easy access from roads. So the site that we've identified is just northwest of the Dairy Research Facility. It is an existing 10-acre alfalfa field. The benefits of that site is that it does stay relatively dry. It's a good size. It's 10 acres. It's very close to the major feedstocks that would be going into that facility, being Dairy Research Facility and the College of Vet Med, and it is not too close to the Urbana neighborhoods. The downsides is that currently there is a stormwater drainage problem. When the parking lot that was built for the College of Vet Med was put in, they didn't take into consideration the runoff that would be generated that's actually going behind the dairy research barns, if I understand that correctly. Is that right, Mike? So that's a fairly major undertaking that needs to be resolved because that runoff could go into this site. There will be some soil preparation or putting down some kind of impermeable pad on that site. And then if Animal Science wants to bring the manure that's generated from the beef research facility down on South Ray Street, you're talking 3 to 4 mile travel distance of a material that's pretty wet. So there would be cost associated with that. The regulatory issues turned out to be very straightforward and really not that cumbersome. We were concerned because the state of Illinois has very non-scientific rules as it relates to composting, particularly when it comes to blending feedstocks. For some reason, they think that yard waste shouldn't be blended with anything, which, for the life of me, I can't understand where that came from. But that's what the rule is right now. And so we were worried that they were not going to allow us to do this blending. But that turned out to not be an issue, that we could actually blend all these materials. We could actually produce a saleable product as long as we got a permit from the Illinois EPA and a local siting permit. And the local siting permit may or may not be an issue if the university has sovereignty over the property and it doesn't have to go before a local government board for approval. If it does, it does add a layer of complication, and there's a lot of variability, a lot of unknowns, and very much dependent on the local government in terms of what kind of hoops they would have the university jump through and what kind of fees they would assess. Throughout the state, this is another enormous problem, is some municipalities or counties charge a few $100s for a siting fee, others charge like $50,000, and so there is that unknown concern as to whether we'd have to go through that process and what it would actually mean. Okay, in terms of the markets, one of the students did a end user survey where she actually called up several end users in the area, basically just taking the phone book and identifying the golf courses, garden centers, landscape contractors, talked a little bit with the grounds people at the University of Illinois, and a little bit with some organic fruit and vegetable farmers to get a sense of whether they're currently using compost, and if so, how. If not, what would they be looking for in terms of the product characteristics? How much would they use, and what would they pay for it? We get the most detailed information from the garden centers, mostly because they currently sell, most of the garden centers in this area sell some type of compost. And so we got information about what they're currently paying for that product, how much they sell, and what they would be willing to pay for a high quality product, because one of their complaints was inconsistency and lack of quality in the products that they were currently getting. So this was all good news in the sense that it's a lot easier to justify the cost of building a facility if you know that you have an outlet for the product. In terms of the financials, the numbers that I have here are very much in flux at this point, because we're not sure who is actually going to build the facility and how they will actually build it and what kind of composting technology they would use. So our estimate is around $500,000 to build a facility, and that includes the cost for actually pouring concrete as an impermeable pad for the active part of composting. And then to operate it would be a little over $80,000, and that is mainly to hire a site manager and someone to operate the equipment. The initial thinking was that the feedstock suppliers would be charged what's called a tipping fee, that is based on the volume of material that they would supply. They would be assessed a fee to process that material into compost, and that fee could be, assuming that the facility took all of their waste or or half of their waste, and could diminish over time, particularly as a revenue source is generated. We assumed that we could probably get $15 a cubic yard for the finished compost, and based on how much compost we thought we would be generating, could result in anywhere from $180,000 to $280,000 of gross sales per year. And so the hope is that this facility would be self-supporting and even profitable within a 2 to 3 year time frame. Okay, so where we stand now is we had kind of a late start in getting our pilot project going, and Todd Rusk is really the person who's in charge of this pilot project, and unfortunately he's not here, but the goal of this pilot project was to compare an aerated static pile system versus a windrow turn system with 3 different compost recipes to look at what's the labor involved in setting these piles up and managing them, and how well do they compost, and what is the quality of the finished product. So we wanted to have 3 recipes that were fairly distinct and that incorporated all of the potential materials that could be composted. So that's what you see here in recipes A, B, and C. It's a research barn that's within the dairy research lab, where they're looking at the effect of day length on milk production, or is that right, or do you know? I think it's just one of the units that they're doing a particular kind of study at the dairy research. And this is just the experimental design, 6 piles, 3 with the windrow turn system, each of the recipes, 3 each of the recipes with the aerated static pile. So we didn't get this going until December, of course, which means that it's really essentially getting it started and then doing nothing because it's too cold to turn the piles or blow air through them. You would absolutely kill the microbes in your pile by doing that. So we did want to at least get it started so that come spring, when air temperatures go up, we could begin to collect some more measurements. And I'll just show you some pictures of them setting up the piles by basically taking the feedstocks and mixing them in a manure spreader, and then shooting it out the side of the manure spreader into the form of a pile. This is how they set up the aerated static pile system. You can see the PVC pipe and the leaves basically serving as this plenum. It's just a way to keep the holes from clogging up in the pipe so you can get good airflow through the pipe. And these are the finished piles. Not surprisingly, given what the weather was like in early December, it took a few days for the piles to heat up. They never even got to what's considered to be thermophilic temperatures, and again, that's not surprising. They had a lot of animal disturbance in the piles that had food waste, which is an issue in terms of management. And then also, this is also typical when you develop these recipes, you don't always have the up-to-date characteristics in terms of carbon and nitrogen, and it turned out that the recipes' carbon and nitrogen ratios, the actual ones, were lower than what we had predicted, which can also, if they are too low, can result in release of nitrogen as ammonia gas, and you don't want that. So where do we stand now? Right now, I mentioned to you earlier that the College of Vet Med has had to remove the material from the Windsor Road site, and because there is no facility to take the material to, unfortunately they're having to landfill that waste right now, which is really not a good situation. The Animal Science Department, or the College of ACES, had decided that They were going to hire an engineering firm to put together a proposal for an actual composting facility on the site that I described to you. They are expecting the final report from that consultant any day now, supposedly, and once that is in hand, then we can figure out what the next steps are. So that's what I had for you, and I thought I would leave ample time to open it up for questions. But they kind of sprung this on us that they were going to hire this consultant as we were finishing up our own study.
What about like drugs that are used now in animals? That might be in animal waste. Are you testing for those, or is that going to be a problem? Or will it go into
The question is any drug residues that might exist in the waste and whether that's an issue. Typically, most drugs are organic in nature, organic compounds in nature, and they, if the material is well composted, they will be broken down, like hormones and antibiotics. Did you want to comment?
Well, actually,
This is Mike. This is my co-conspirator in the back here, Mike Beal from the College of Vet Med.
with regard to that, any concerns about that? I mean, you're right, they'll be broken down, but they'd be also so diluted through the whole composting process that we know it's not whatsoever that. I do want to add too, we didn't, on the winter side, we weren't able to remove the current material. That would,
Oh.
we're going to fully stop adding material.
Okay.
Fully composted, and actually that's probably going to be removed. Historically, this has existed for over 10 years, long before I got there. We have local farmers that take this material and spread it on the field. She's going to be removing that for the last time for sure.
Okay. So there was, though, concern. Campus safety, it was concerned about sharps in the bedding from Vet Med, and that is something that will just have to be monitored. I mean, there's a lot of education within the teaching facility to not just throw needles when they're done with them, but you know how that goes.
Well, it's they drop from the idea of those or something. But we can put screens in part of the composting process to take care of it.
Yeah.
How do you look at the levy situation in terms of the constant production of things like feed from the dormitory, things like that, and adding and turning of the cold like 3 or 4 months of the year? Is that something you're comfortable with that? Like, what do you do with all that stuff when you can basically pile in your waste?
That's a very good question in terms of the constancy of certain types of waste that are really wet and really odor producing and break down really quickly, like food waste. And typically what other campuses that are doing food waste composting do is they will blend it with something like the stockpile leaves or some high carbon material, blend it with that material, but not try to actively manage it during those really cold months, because it will be very counterproductive and actually make it even more difficult to get the temperatures going once the air temperature warms up. So that's the good news about the cold temperatures, is you're not going to be generating, it's not going to really break down, you're not going to really get odors. You just want to get it contained and prevent that material from becoming soupy and, disgusting, basically.
Anyone here on campus support possibly waste as a feedstock for livestock?
I didn't quite hear the
Does
question.
anybody support using food waste from the cafeteria as a source for feed for livestock?
Okay, the food waste as a source for livestock feed. I don't know. I don't think so. They certainly are looking at ethanol byproducts as a source of feed for livestock, but as far as I know, I don't think they are. But it certainly is an interesting idea and should be explored. Yeah.
Has Alan Hall, which is the environmental one, looked into trying to put a sign or something to suggest to the students that half of the food waste is stuff that was put on a tray by somebody whose eyes were bigger than their stomach? Maybe they should only take what they might eat and go back to
That's a,
That would make it interesting study in itself.
it would.
Science, even a little simple education.
Yeah, that I think I think it would be also interesting to look at the characteristics of the waste from an a la carte dorm where they don't have the option of limitless amounts of food. They're paying based on what they actually put on their tray. From what I understand from other schools that have done these kinds of waste audits, that you may get less food waste on the trays of those a la carte type dining halls, but you get more contamination. Mainly because the students are the ones that sort or throw away what's on the tray.
A question. In terms of all the food waste on campus, I mean, it seems like the objective isn't to try to capture everything that's compostable on campus.
Well,
but if we were to try to have a campus-wide composting strategy, would this be the technology to use? It seems like we'd have even more liquid, high moisture content material, and need even more of the dry material.
we
for
would.
those issues.
Yes, that's a really good point. I think we have no idea how much total food waste is generated on this campus. There's no way that I would feel comfortable extrapolating from what we audited at Allen Hall to any other dorm, let alone the Union.
Athletic department.
And right, exactly. And I think if the goal was to compost all of the organic waste generated on campus, we would have to really take a look at the food waste and figure out if it's even feasible. My gut feeling is that with our current source of drier, high carbon materials, even taking all of the leaves from the city of Champaign, and even if we could convince the city of Urbana to shut down their facility and send all of their leaves to this facility, I still don't think we would have enough carbon to solve that. Which gets back to the point of, why are we generating so much food waste? And I think that is a really excellent question to be asking.
The campus has an office recycling project. Would that be a source of carbon?
Well, the office of recycling is mostly non-compostables. It's like glass.
Paper products.
Oh,
Like office paper.
right. It could be. The problem with those materials is that, yes, they're a source of carbon, but their physical characteristics are not. You want kind of a blend, like leaves and brush and shavings type bedding. Those are excellent carbon feedstocks for composting because they have a physical nature as well as the chemical nature that they don't break down really quickly. They provide some structure that keeps those piles porous so that you have good oxygen. And so newspaper and office paper, they're really difficult to blend. They tend to kind of gum up themselves or blow all over the place. There's a lot of problems with waste paper as the main carbon source. And I think they make a pretty good amount of money on recycling that, through the channels that they do. So I think it would be difficult to convince them to divert that towards composting.
What about worms? I have friends who have these little bucket tins of things for their food waste, and they use the worms. Can that be done on a big scale?
It is being done on a big scale in some places. It's a totally different technology. It doesn't rely on heat to kill pathogens. Some people are doing kind of like a two-stage where they pre-compost or compost using high temperatures and then use worms for the curing phase, like in Oregon, Evergreen State College actually has that kind of a system. But it's a lot more difficult to manage on a big scale. It's well suited to home scale composting or even school elementary school kind of scale composting. But when you're talking about the volumes of material that we are here, it's difficult to manage those well and not have odor problems, not attract flies and things like that.
Yeah, on one of your slides, you said that the piles you made out there have not yet reached a certain temperature.
Right.
Was that 113 degrees?
Well, 113 degrees is the beginning of what's called the thermophilic range, meaning that there's a certain population of organisms that thrive between 113 and like 160 degrees Fahrenheit, and the temperature that is considered critical to hit for pathogen destruction is like 130 to 140 degrees. So, but the minimum value for that thermophilic range is 113 degrees. But
you mentioned weed seeds also. Will that kill the weed seeds?
yeah, that'll kill weed seeds. Depending on the type of seed, will be killed in that 120 to 150 degree range, and some weeds will be killed in a matter of days, and others in a matter of weeks. Yes.
You also mentioned in passing that you had wild animal strategy.
Yeah.
How in the world do you control that?
Well, it's a problem, and partly with these small piles where you have, it's difficult to hide the stuff that's attractive to them.
Build it up to 5 acres. What do you do? Fence in 5 acres?
The whole site will be fenced.
It will be, yeah.
Yeah, I think
Even then, you're still going to.
even then you're still going to have rodents, and I mean it's just one of those things where you try to build piles in such a way that stuff is buried, but it's really difficult. It's going to be difficult. Yes.
Illinois has some pretty permissive regulations in terms of composting. Are you noticing there's trends or other regulations at other state levels that might impact these particular facilities and so on?
Well, I mean, this facility, composting is regulated at the state level, so I doubt that there would be other state regulations that would impact this particular facility.
But other regulations they don't want to adopt?
Oh, they might, but I don't know. I mean, there was a movement a few years ago to do some reforming of the regulations to make them, more science-based, and I don't think that has gone anywhere. But there are other states that have models that are more science-based that would facilitate composting as opposed to make it more difficult to compost and compost properly.